So I have here a warm-up on the board. You can go ahead and try it and let me know when you are done. So if you look over there, on the full whiteboard I have on the right a list of steps that we can always use to factor. I'm going to start with my step 0, which we added last week. Step 1, which is to look for common factors. So looking here, you all could type it in. What's my greatest common factor going to be?
Why you pause it?
Part of it is 3. There's one other common though.
I'm taking me off.
Yeah, we're gonna go with 3x. Right, and so then we end up with 3x to the third.
Wesley.
3x. Everything okay? And then we have 3x times x squared minus 7x plus 10. And that looks way more friendly to factor. So we can go ahead and just factor this part now.
Wesley, don't do that.
So we put x box, x squared, and 10.
Just win. Just win.
Just win.
We'll fill in our diamond.
It's
And x. Adding up to 7x. Here. And then the two numbers that we're looking for, we either have 1 and 10 or 2 and 5. Either those are going to work. So let's try making those negative. And so we get negative 2x and negative, well, that's not a 5. Negative 5x. So now we're ready to find x minus 5 and x minus 2. So we can write our final answer, not forgetting our 3x. 3x times x minus 5 would be our fully factored one. Does that make some semblance of sense? Hopefully. It's so we're not seeing your faces. Okay. So then to graph same inner expression, x squared minus 7x plus 10. And when you graph it, you should end up with something like so something like that, although Desmond probably did it a lot prettier than I just did. You were able to find the Desmond calculator online?
Look at what happened. Look at what happened. They're bread.
Mm-hmm.
They're bread.
All the way down.
Is anyone there?
Really say, hey, what's your car?
So Matt, Elizabeth, Yufon. Matt? Maybe not. Okay. Well, so then we can identify our intercepts. So our x-intercepts are going to be on our x-axis. So
I said, they hear that?
You're what?
I said,
and then our y-axis are going to be on, it's just going to be the y-axis and the one right here at 0. So I want you to take a moment and think about how is that related to the numbers that we found, right? So we're dealing with this, and we know that the way that it's factored is x minus 2 times x minus 5. So take a moment to think about how are here related to the two forms of the equation. So you may notice
silly game.
are here.
That's silly game, Mama. That's silly game.
Funny game.
All right, and then in this right here, sitting in the back, we're going to get into in next week. We're going to be looking at like the useful part of all this factoring that we've been doing. So why have we been doing all this? It's really great for understanding the graphs of quadratics because it reveals to us what the x-intercepts are. And then in the standard form up here, just the one that wasn't factored, our y-intercept is sitting right here. So that's kind of cool. What questions do you have? Let me see if I can make a poll. Why did that option go away? Ooh, exciting. All right, so I think I just posted a poll. Just to see how you all are feeling about these problems. So we're going to factor, you're going to graph, you can decide, maybe you can predict what it will look like, and then you can confirm it with part B. When you factored it, you got x minus 6 times x minus 2. And then when you graph it on Desmos, you should get something like that. And then our x-intercepts were at 2, 0, and 6, 0. And the y-intercept was at 0, 12. Right, so that's here on the y-axis. And to connect it back to the equation, in that first form, we call it standard form. In that first form, x squared minus 8x plus 12, it's that last number, the constant number, which makes sense because if you plug in 0 for x, then you get 0 minus 0 plus 12, and that's the definition of our y-intercept. And then for our x-intercepts, they were here. And as predicted, they were here. And so one thing to keep in mind is this minus sign out in front. So if it's x minus 6 and x minus 2, we end up with positive 2 and positive 6. If in an alternate reality we had been graphing x plus 6 and x plus 2, you can think for yourself, how do you think that would look different? Or would it look the same? So squeaky. So what you'd actually do, it would be the opposite. So it's always the opposite of this number, and we'll talk about why that's the case at some point this week. So we end up with negative 2 and negative 6. Kind of the same thing, just mirrored across. And that's all I have for you today. Oh, Anson's here. Hi, Anson.